All right, lesson 28 deals with factorials, and then we're going to look at some abstract rate problems. Okay, factorials, when we talk about factorials, it usually deals with probability. Probability, there's going to be a time where it's going to be necessary in order to come up with the product of a number and its consecutive descending integer factors. So, for an example, if I told you what is 4 times 3 times 2 times 1, that is what we call 4 factorial. Now, factorial, to represent that, they show it with an exclamation point behind it. Now, I've had students in the past say, oh, we're talking about excited fours today. And that's not necessarily what the exclamation point means. Now, mathematicians like to use this notation to represent that consecutive integer multiplication, because if I told you what is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, it's a lot easier just to say or to write 12 factorial than it is to write all of those factors. So the first thing that they're going to ask you to do is just to evaluate a factorial. So if they said evaluate 5 factorial, that is 5 times 4 times 3 times 2 times 1. So 4 times 3 is 12, 5 times 2 is 10, 12 times 10 gives you an answer of 120. Now they're also going to ask you to evaluate, without using a calculator, something like 9 factorial divided by 3 factorial, 5 factorial. So if I think about what 9 factorial means, it means 9 times 8 times 7 times 6 times 5. And then if I wanted to, I could say times 4 times 3 times 2 times 1. But I know that all of this right here is just the same thing as 5 factorial. So when I look at what the denominator is, which is 3 factorial times 5 factorial, the 5 factorials cancel, and I do not need to necessarily write out 5 times 4 times 3 times 2 times 1. If I think about 3 factorial, that's 3 times 2 times 1. Well, 3 times 2 is 6, so 3 factorial cancels with 6. And what I am asked to calculate then is what is 9 times 8 times 7. And it doesn't matter which way you multiply it in or anything like that. So I don't care if you go 56 times 9, if you go 63 times 8, if you go, it does not matter. So anyway, if you were to take 9 times 8 times 7, you're going to end up with the value of 504. So if I were asked to evaluate 14 factorial over 6 factorial times 11 factorial, so I would look at 14 times 13 times 12 times 11, and then I'm going to put factorial because that is my largest factorial in the denominator. So I have 6 factorial times 11 factorial. Now the 11 factorials cancel. So in the numerator, we are going to have, I'm trying to figure out where to write it, 14 times 13 times 12, and the denominator of 6 factorial is 6 times 4 times 3 times 2 times 1. So if I look at it, I could say 6 times 2 is 12, so I'm going to reduce that. Other factors that reduce, 2 goes into 4 2 times. 2 goes into 14 7 times. So I'm going to end up with 7 times 13, which is 91, over 10 times 3, which is 30. So you end up with 91 over 30. Okay, something else that they might ask you to evaluate, and they may say use the factorial key on your calculator, is they're going to say evaluate 11 times 10 times 9 times 8 using the factorial key on your calculator to help you. Well, I know that 11 times 10 times 9 times 8 is taking on the pattern of 11 factorial. That would be the case if I also had the rest of the remaining digits there, which would be 7 factorial. If I were to divide that by 7 factorial, I get down to what my original problem is, which is 11 times 10 times 9 times 8, because the 7 factorials would cancel from each other. So the numerator is a value of 11 factorial, and the denominator is a value of 7 factorial. That means the same thing as 10 times 9 times 8. 11 times 10 times 9 times 8. So if you were to look at your calculator, there is actually a way that you can find the factorial key if you have the TI-84 plus is what I'm using right now. So you would type in 11, and to find the factorial key, there's one student that I know does not have the graphing calculator. So if you need help, make sure you contact me and I can help you find that factorial key. But you hit this math key on the TI-84 graphing calculator, and if you were to move over to probability and you go down to number 4, you see that that does happen to be the factorial key. So we end up with 9 factorial, or that is 11 factorial. I should have done this differently. I hit equals and I shouldn't have. But what we want to do is we want to take that 11 factorial and we want to divide by 7 factorial. And 11 factorial divided by 7 factorial gives you an answer of 7,920. Now if I took 11 times 10 times 9 times 8, you get the 7,920. So the factorial key can help you in your multiplication. It is a big component when you start talking about probability. Okay, the next thing we want to look at in lesson set 28 is abstract rate problems. Okay, the train traveled at p miles per hour and still arrived 1 hour late. How fast should the train have traveled to have arrived on time? So if I look at this problem, we've already talked about rate problems, and we looked at them in this type of format. And I still set up the same boxes, even though we don't solve them with elimination substitution like we did previously. Distance is equal to rate times time. These are abstract problems because you don't have a number. You're going to have a variable as part of your answer or within your answer. So the first thing that we look at is we take this first piece of information where units are going to be a big thing. So you have m miles, that is your distance, and you travel at p miles per hour. Underline all of it. P miles per hour is a rate. Now you don't know, you have no idea what this time is right here. It's unknown. It's not a numerical value. I don't have a variable to represent it right now, but I know that that is 1 hour late. So just keep in mind that this is 1 hour late. Now, if I wanted to solve for time, it is being multiplied by the rate. So to get rid of it, I would have to divide by the rate. So I know that if I take distance, which is m, and I divide by time, which is p, that's going to give, divide by rate, which is p, then that's going to give me my time, which in this case, my time would be m over p. Now keep in mind that this value is 1 hour late. So now we're going to go through and look at the next part of the particular problem. And the next part of the problem says, how fast should the train have traveled? So now what I am looking for is let me get a different marker here. I am looking for how fast should the train have traveled. I am looking for this box that I am highlighting in orange. How fast means a rate. How fast should the train have traveled to have arrived on time? Well, it's still going to go that distance of m, and I want it to arrive on time. Now, this is where we have to think a little bit. M over P was how long the train had traveled before. Say that took him 5 hours, because remember T is your time of travel. It took 5 hours for the train to get there, but he was 1 hour late. So to arrive on time, I have to take an hour off of that. So if he would have traveled for 4 hours instead of 5 hours, he would have been on time. So I need to represent my time as M over P, but I have to take 1 hour off of it to arrive on time. And now I am looking for the rate, or this orange box. So I know that my distance is equal to my rate times my time. So to get rid of it, I need to divide. So to solve for that rate I would have to travel, I would need to take my distance, and I would have to divide by my time. Now that is a complex fraction, so I need to take that denominator value and write it as one fraction by getting a common denominator, which we have talked about. So I want to make this P over P, so I can write it as one fraction, M minus P over P. And now you flip and multiply. So you're going to take M times P over M minus P, and we would find out that the train would have to travel MP over M minus P miles per hour. Abstract problem because you have variables involved. Now I have about 4 minutes and I'm going to show you another example. Okay, the boat traveled at K miles in T hours and was 40 miles short of the goal when the gun went off. So the first piece of information, the boat traveled K miles. Miles, that's units for distance. And it traveled that in T hours, so that is my time. And this is 40 miles short of the goal. That 40 miles short of the goal is going to play a role in the next part. But if I know the distance and the time, then I need to find, the first thing I need to find is that yellow box. What was the rate? So distance equals rate times time. So if I were to set up that equation, this is being multiplied. Inverse operation is to divide. So my rate is K over T. Now the next part then says, if the skipper tried again, how long would it take? So what you are looking for in that case, how long would it take? That is looking for time. How long would it take to have reached the goal if she increased the rate of travel by 10 miles per hour? Now we know that this K miles is 40 miles short of the goal. And in the next part, they want to reach the goal. So that means I'd have to travel the distance of K plus another 40 miles in order to reach the goal. Now the other thing is that I am going to take my rate that I traveled before, which is K over T, and I need to increase that by 10 kilometers or 10 miles per hour. So what we have is we have this K plus 40 is equal to my rate, which is K over T plus 10, times my time, which is unknown. So I'm just going to let that be my question mark and not represent a T, because I already have a T within my problem from the previous time. So I need to solve that. So in order to solve, I'm going to simplify the right-hand side of the problem first, and I do that by getting the common denominator of T. So it becomes K plus 10T divided by T times the time that I am looking for. So to solve, I am going to have to divide by K plus 10T over T. But when you divide by that, you flip it and you multiply. You multiply by the reciprocal. So I'm taking K plus 40, and I am going to multiply that by T over K plus 10T. So the time that it's going to take me is going to be, so my hand was covering that up. The time that it's going to take me is just going to be the product of those two. So it's going to be K plus 40 times T over K plus 10T. And your units for time, if I look back in the problem, is labeled in hours. So it's going to take me that many hours in order to reach my goal. Now,